Hi, everybody. This is 4.3. We're on page 153. Follow along in your book, please. Solving inequalities. The thing that is going to make this very, very, very simple for us is to keep in mind that when you solve inequalities, that you are doing exactly the same things that you would do if you were solving an equation, okay? The steps are exactly the same. Just please, as you are solving inequalities, do not make the mistake of replacing the inequality symbol with an equal sign. At least a third of you will do that. Okay, you will get to the bottom of solving your inequality, and all of a sudden, you're going to have that x is equal to some number, when this is not equality, this is inequality. So that is the only thing that you really need to pay any attention to that makes this any different than solving equations. This is example 1, very basic. Because you guys are masters at solving equations. We know that we subtract 5 from both sides and then divide by 3, okay? Which gives us that x is greater than 5. Very, very simple, okay? Moving on to example 2, we have negative x over 3, and again, we need to remember that negative x over 3 can be rewritten as negative 1/3 x. Now, in my opinion, that's what makes this a little bit easier to solve, okay? So we'll start with the rewrite. Because if you look up in the original statement, we actually do have a 1x there. You just don't see the 1 because it's not necessary to put the 1 there. However, rewriting it as negative 1/3 x is going to help us in determining what we need to do to get this inequality solved, okay? Because remember, when you've got a negative stuck to your variable, by multiplication or division, you need to switch the direction of the sign. So that's why I rewrote it, to intentionally point out that that 1/3 x is negative, and the implication of that is that the sign is going to change direction. Okay, so we are going to start by subtracting 8 on both sides, just like we would if this was a regular equation. Okay, now, here comes the part where we are going to use our reciprocal, okay? So negative 1/3 can be canceled out by multiplying by its reciprocal, which is negative 3/1. The 3's divide away, the 1's divide away, and negative times a negative gives us a positive x. Now, because we multiplied by, just by multiplying by negative 3/1 on the left, we're going to multiply by negative 3/1 on the right, which is going to give us negative 12. Now, the only thing left to do is switch the direction of the symbol, okay? So now x is less than or equal to negative 12, okay? If we did have to graph that on a number line, remember, less than or equal to has a filled in hole, and the numbers less than negative 12 go to the left. Okay, very simple. Okay, now, example 3, a little bit more involved because we have some distribution that we need to pay attention to. And when we distribute, that is going to cause us to need to combine like terms. So in the distribution, 3 negative times a positive 2 is your negative 6. And then negative 3 times positive 2x is negative 6x. Okay, now on the left side is where we're going to do some combining of like terms. X's go with X's. So we have 4 of them. Our signs are different. The 4 is positive. The 6 is negative. When your signs are different, you subtract and keep the sign of the larger. So 6 minus 4, x's that is 2x. But because the 6 is negative and 6 is a bigger number than 4, our 2x is also negative. Okay, then we also still have a minus 6 is greater than 10. Okay, now we're at the point that we were in examples 1 and 2. We are going to isolate the x term, in this case by adding 6 to both sides, which gives us the fact that negative 2x is greater than 16. In order to isolate the x, we divide both sides by negative 2. X on the left, negative 8 on the right. But because the x had a negative number stuck to it, when we divided away the negative, we have to switch directions of the sign. Now I'm going to show you why that's true, okay? We are going to go back to the statement negative 2x is greater than 16, okay? We're going to start from there, and we're going to divide both sides by negative 2, but instead of switching the sign, we're going to leave it, okay? And we're going to pick a value for x. We're going to plug it in. So let's pick the value 3, okay? If we put a 3 in here, we get that negative 2 times 3 is negative 6. Is negative 6 greater than 16? No, it's not. That's why we need to change the way that the symbol or the inequality symbol is facing. So when you divide by that negative, we would get that negative 6, for example, if x is 3, is less than 16. That's why we have to change the way the inequality faces, because that, without changing the way the sign faces, your inequality statement is no longer true. So that's why you need to change the way the sign faces. Okay, very simple. All right, moving on. Again, I want to stress the simplicity of this is because you know how to solve equations as well as you do. Okay, example 4. We have x plus 4 greater than or equal. Now here we have x's on both sides of our inequality. Now most people I find are more comfortable when the variable is to the left of the inequality. I am also more comfortable that way. So when we work through this, we can move our variables from the left side or the right side over to the left side. But before we do anything like that, we have to distribute. So let's get that done first. X plus 4, so 5 times x. X plus 4 is greater than or equal to 5x plus 30 and minus 2x. So on the right side, we'll continue to simplify by combining like terms. 5x's minus 2x's gives us 3x's plus 30. Okay, now we're going to move the 3x over here by subtraction. Okay, so we'd have negative 3x plus x plus 4 greater than or equal to 30. Now we're going to move the 4 over by subtraction. Again, you'd be doing this exact same thing if you were solving equations. And 30 minus 4 is 26. Okay, so what we've got now is the need to combine the like terms on the left. we have -3 plus 1. The signs are different. Subtract and keep the sign of the larger. So 3 minus 1 is 2 x's, but 3 is the bigger number, so 2x is negative. Okay. Divide by -2. And because the 2 is negative, when we divide and get -13, we change the direction of the symbol. Okay, I'm sure by now this has definitely sunk in. One more, we have a story problem. Aren't you just thrilled? Okay, Jeffrey wants to fence in a rectangular garden. Okay, so he's got this garden. Now we know when you fence something in, you're talking about the outside, which the outside measure of any shape other than a circle, the outside measure of any shape is what we call the perimeter. Okay, so he is fencing in a rectangular garden and he has 60 feet of fencing. That means the perimeter is going to cover 60 feet because that's all the fencing he has to go around that property. If the width must be 5 feet more than half the length, yikes, what are the possible dimensions of the garden? Okay, so this is the length and this is the width. Okay, well, as it stands, if we write the perimeter equation, which is twice the length plus twice the width, and P is equal to 60, right now the problem that we have is that we've got two unknowns, L and W, and that's too many unknowns for one equation. You're only allowed one variable, and we've got two different variables, and that is going to be a problem, okay? So we're going to go back to the sentence that says the width must be, so the width is 5 feet more than half the length. So half the length is 1/2 L, and then 5 feet more than that. When we use that now as a substitution, 60 is equal to 2L plus 2 times what W is equal to. So when we do that, we only have now one unknown. The length is our only unknown. So we can distribute there because the goal here is to find the possible dimensions of the garden. And actually, my fault, and I just made the mistake that I asked you guys not to make. I used an equals sign. Now, in as far as the perimeter formula goes, that was not a mistake. Okay, that is the perimeter equation. However, if we only have 60 feet of fencing, we can't use more than that. So twice the length plus twice the width cannot be, it has to be less than, it has to be less than 60 feet. So let's rewrite that and rewrite and put the inequality. All right, so 2L plus 2W has to be less than or equal to that 60 feet of fencing. See, I made that mistake. Going through the inequalities, it is so simple to just stick an equal sign in there, and that's not actually what we need to do. We're inequality because you can't use more fencing than what we've got. So we will use this inequality statement with the substitution of what W is equal to. Okay, so 2L plus the substitution of what W is equal to, and then we'll be able to solve the inequality. Okay, now we are where we need to be. 2 times 1/2 is just 1, because the 2's are going to cancel, right? And then 2 times 5, both positive, is plus 10. Less than or equal to your 60 feet of fencing. So we have 3 L's plus 10 on the left is less than or equal to 60. So we're going to subtract 10 from both sides, just as you would an equation, to get that 3L is less than or equal to 50. And when we divide, we get that L is less than or equal to 50 over 3. Now that's a little bit difficult to determine what the length is actually, if it is 50 over 3. So when you divide 50 by 3 on your calculator, you're going to get 16.666666666 forever, which is 16 2/3. So the length cannot be greater than 16 2/3. Okay? Now that we know what the length is, then we can determine what the width is. Okay? So if the length is less than or equal to 16 2/3, the width is going to equal 1/2 of the length plus 5. Okay. So I'm just going to leave that for now, as the inequality is the more important of the concepts here. Okay. Change your fraction to an improper, do your keep, change, flip thing, find a common denominator. That's how you would finish solving for the possible lengths of the width. Okay. All right. So we have concluded another lesson. Okay. Your homework is going to be given to you by your sub. Have a good day, guys. Bye.